This is 2008, FRQ number 6, still in the non-calculative portion. All right, so let f be the function given by f of x equals natural log of x over x for all x greater than 0. The derivative of f is given by here. Write an equation for a line tangent to the graph of f at x equals e squared. Okay, remember, tangent line, that means we need the slope, which I already have, which then means I plug in the x value to get my slope. And I also need to plug in my x value into the original function to find my y values to write my equation, okay? So, doesn't matter which one you start with, but I'm going to start with getting the y value. So, f of e squared equals natural log of e squared over e squared. Well, natural log of e squared, the natural log and e will cancel each other out, bring down the 2. So, it's really 2 over e squared, all right? F prime of e squared, plug it into the derivative function, 1 minus natural log of e squared over e squared squared. That gives me 1 minus 2 over e to the 4th, which is negative 1 over e to the 4th. Okay, pretty gross, but that's our slope. Okay, and that's our y value. So y minus y1, right, equals slope m x minus x1. I believe this is totally fine. You can leave your answer like so. If you so inclined, you can just add the 2 over e squared over to the other side. Doesn't really make much of a difference in terms of cleanup. It doesn't really clean up. So that's it for the line equation, the tangent line. All right. Part B. Find the x-coordinate of the critical point of f. Determine whether this point is a relative min, max, or neither for the function. Justify. So to find a critical point, we set the first derivative equal to 0. Very nice. So we go 1 minus natural log of x over x squared equals 0. Remember, we take the top and bottom separately equal to 0, right? We really don't need to take the bottom equal to 0 because if you recall, the bottom will only give us cusp or vertical tangents or places where it doesn't really have a derivative. So what you really want is take the top, right? So 1 minus natural log of x equals 0. That would give me 1 equals natural log of x, e to the both sides to get rid of the natural log. So x equals e to the 1 or e, okay? So how do I know that is a relative max or min? Well, we do our number line test. We put e here, right? Well, how do we know what e is? E is approximately 2.7 something. So if this is about 2.7 something, you want to test f prime of 1. I think that's a really nice number. And we can test f prime of 3. 3 would definitely be bigger than e, all right? So what would that give me? Well, f prime of 1, it'll get 1 minus natural log of 1 over 1. Well, 1 minus natural log of 1, that's 0. So 1 minus 0 over 1 is 1. That's positive, so it's increasing. What about 3? So 1 minus natural log of 3 over 3 squared is 9. Well, natural log of 3 is going to be a number bigger than 1, right? How do I know that? Let's see. Natural log of 3 equals what? You can look at it and say e, right? So 3 equals e to the what power? So e to what power would give me 3? E is already 2.7. So for 2.7 to what power to equal 3, that number has to be bigger than 1 because I need to get bigger than itself, right? So if that number is bigger than 1 minus a number bigger than itself is going to be a negative number. So it's going to come down. So that proves to me that the slope changed from increasing to decreasing. Therefore, it is a maximum at x equals e. All right. Part C. The graph of the function has exactly 1 point of inflection. Find the x-coordinate of this point. Oh, this is the fun part. So for the point of inflection, you want to find the second derivative instead of equal to 0. You're already given the first derivative, so you're going to find the second derivative from what is given to you. I would strongly recommend using quotient rule. All right, so you have this function here. So let's start by finding the second derivative. Okay, low d high minus high d low. So low d high, 1 is gone, negative natural log of x becomes negative 1 over x, minus high d low all over low squared. So x squared squared is x to the 4th. Okay, so let's clean up. This x squared over negative x gives me negative x minus 2x. I'm distributing this through. And then minus a minus plus 2x natural log of x over x to the fourth. All right. Now, they all have an x, so factor out an x to reduce that. So factor out an x to negative 1 minus 2 plus 2 natural log of x over x to the fourth. That gives me negative 3 plus 2 natural log of x over x cubed. All right. So this, how do we know when does this give us a, does this give us a point of inflection? We got to set this equal to 0, right? So set this equal to 0. Now we take the top and bottom separately equal to 0. We don't really have to take the bottom equal to 0, but you can. If we take them separately, you will see that this gives me x equals 0, right? Cube root of both sides, x equals 0. But this value does not exist in the original function because that will make it undefined. So this actually is not useful to me. So what is useful is this one. 2 natural log of x equals 3. Natural log of x equals 3 halves. 3 halves, sorry. All right. 3 over 2, then e of both sides. X equals e to the 3 halves power. Okay. So this is going to be, what is it looking for? Find the x coordinate of this point. This is my point of inflection, x value. Okay. All right. It doesn't say to justify, so I actually don't need to worry about this. But if it does want you to justify, you want to do a number line again, and e to 3 halves and test. E to 3 halves, I'd probably test 0 just so it's a little bit easier, or even just e, right? E is definitely smaller than that. And test e squared because e squared is bigger than that. And y, e, I think because of the natural log, it makes it a little bit easier to test. All right. Okay. Last but not least, find the limit as x approaches 0 from the right side of f of x. This was a little bit tricky because it's not natural for us to figure out what a natural log of x over x looks like. So I actually had to consult another teacher about this, and what he said was that you need to know that the graph of natural log of x. So natural log of x looks, y equals natural log of x looks something like this, where it's asymptotic to the y-axis, right? And so natural log of x over x is very similar to this function. And so because they're very similar, the behavior is going to be the same. So coming from the right-hand side towards 0, the limit as x approaches 0 from the right side of our function, natural log of x over x is going to be very much like this. So it's going to be negative infinity. Okay? All right, that's it for number 6.